Hi, and welcome to IV Tutor. In this video, we want to look at graphs. And we're going to be looking at the shortest path algorithm. The best way to explain this is to just do examples. So let's just go straight into questions. Okay. So what you see here is a graph. So basically a graph is made up of nodes that are connected to each other, which means here we've got this node 0, which is connected to node number 1, which is connected to node number 4. So you can see that each link from one node to the next has a direction. So which means you can move from 0 to 4, but you cannot move from 4 to 0 because of the direction. So you can only move in the direction that is given. That's one thing I want you to know. And then if every link to a node has a weight, this weight represents anything. In this case, it represents distance, which means the distance from 0 to 4 is 2, the distance from 0 to 1 is 6, and so on. From 0 to 3 is 3, from 3 to 2 is 2, So in this case, each path has a weight, in this case, which represents a distance. The purpose of the shortest path algorithm is to help you find the shortest distance from 0 to every other node on the graph. It helps you to find the shortest distance from 0 to every other node. So in other words, you're saying, what is the shortest distance from 0 to 4? What is the shortest distance from 0 to 2? What is the shortest distance from 0 to 1? Like in this case, you can go this way, you can go this way, you can go this way, you can go this way. So there are like 4 ways to get to 1 from 0. But which one has the shortest distance? So that is the objective of the shortest path algorithm. And to do that, the shortest path algorithm uses 2 arrays. One that is called smallest weight, another one that is called weight found. And these 2 arrays are constantly being used to keep track of the shortest distance from 0 to every particular node. So when you do the shortest path algorithm, you draw a table that looks like this. Okay, I'll keep my graph on the side here so that we can quickly reference it. And let me just make sure that we can see clearly what these nodes look like. So we've got that. We've got 1 here. We have 4 here. We have 3 here. So these are our nodes, and I think everything else looks fairly clear. So what you do is you draw a table. And on each iteration, you are going to be updating the smallest weight array and the weight found array. So on each iteration, you're updating these 2 arrays. Then you go to the next iteration, the next iteration, the next iteration. I don't know why I forgot to put smallest weight and weight found here. Okay, sorry about that. Okay, so on each iteration that we do, we are going to be updating the values of these 2 arrays. First iteration, second iteration, third iteration, fourth iteration, up to the 5th iteration. The smallest weight array is used to keep track of the weight, the current weight from 0 to every node, which means here we are keeping track of the weight from 0 to node number 1. From here, we are keeping track of the weight from 0 to node number 2, 0 to 3, 0 to 4. The weight found array is used to determine or to confirm whether or not this weight is the shortest weight, is the smallest weight rather. If this is distance, we are saying, can we now confirm that this distance here is the smallest or the shortest distance that we can ever have from node number 0 to this node? So this is a Boolean array. The weight found array is Boolean, which means you only put true, false values, nothing else. True, false values, nothing else. And this here is your weight array. In other words, you put the values of the numbers that are representing the distance, in this case, from node 0 to that particular node. So we're going to do 2 examples and walk through what happens on each iteration until you get to the final iteration. And it's an algorithm, which means you have to practice it a couple of times so that you can get a hand of how it works every single time. But for the first time, it may sound a bit confusing, but once we do it a couple of times, you will see that, oh, it's just a rhythm. Once you get how it works, you just apply that algorithm, more like you do with other algorithms, like the binary search algorithm. That's how this works. All right, let's go. So when you start, you are on node number 0. So what I'm going to do is I'm going to tick or mark every node that I have visited or where I've been. So I'm going to start from 0. I can just tick like that I'm here. In other words, I'm on node 0. So smallest weight is saying, what is the smallest weight of moving from node number 0 to node number 0? It's 0 because you're already there. So every time when you start, this is just like always, the weight from node 0 to node 0 is 0, and you can confirm that this is the shortest weight to move from 0 to 0. So every time when you start, 0 carries a weight of 0, and the weight found value is true because you are saying, well, I'm on 0, there's no other best or shortest distance to move from 0 to 0, except that I'm already here, so you can confirm. Now, here's what you're going to be repeating every single time. What I'm about to do now, this is going to be repeated as you move to every other node, okay? So we are on node number 0. And this is what you're going to do. You're going to say, where can I go from 0? In other words, you're looking for nodes that are directly connected to 0. And remember, you can only go in the direction of the arrow. You cannot go opposite direction. So from 0, you can go to 3, you can go to 4, you can go to 1. Okay. So then you say, what is the weight of moving from node number 0 to node number 3? It's 3. So this is 3, and you make it false. Okay. So for the first iteration, there are certain things I'm not saying right now because it's the first one. But when you go to the second and third, you will identify what exactly you will be doing. But for the first one, we just put 3 here, and we make it false. Always make it false. From 0, you can go to 4 with a weight of 2. So this is 2, and you make it false. From 0, you can go to 1 with a weight of 6. So this is 6, and you make it false. You're done. So everything else is marked as infinity because you assume the worst. So every other node that you cannot visit from 0 right now is marked with an infinity, and you make it false. Now, here's what I want you to remember every single time. This is what's now really important. When you move from this to the next iteration, there are basically 2, 3 things that you're going to do. I'll write these things down here. Right. Number 1, when you move to the next iteration, the first thing you want to do is copy everything that's already true. Everything that's already true. Right? So you copy 0, true. Is there anything else that's true already? No, it's only this one, right? Step number 2, identify the node with the smallest weight. In other words, we are saying identify the node that is closest to 0 after doing the first iteration. In this case, it's node number 4. You bring it down and you make it true. So you go to here, true, right? Bring it down or copy it and make it true, right? Step number 3, go to graph, repeat process from current node. So what you're doing is you're saying, okay, 4 is the one with the smallest weight. So you bring it down, you make it true. Then you go to your graph. You are now on node number 4. And you repeat the same process that you've done when we were at 0. So I want you to take note that the only time you convert a node from false to true is when going to the next iteration. And this is how it's done. Pick the one with the smallest weight, move it down, make it true, go onto your graph, repeat from that node. So now you're on node number 4. And the question is, where can you go from node number 4? In other words, which nodes are directly connected to node number 4? And you're looking at only nodes that are still false. So the ones that you have ticked, ignore. So from 4, we can only go to 1, right? So you can only go to 1 from 4 with a weight of 2. What this means is the weight of going from node number 0 to node number 1 via node number 4, because you're node number 4, is 2 plus whatever the current weight of 4 is. In other words, if we are speaking of distance, we are saying the distance from 0 to 1 via node number 4 is 2 plus whatever distance it is to move from 0 to 4. So what you do is to update 1, you take the weight of this path from 4 to 1, which is 2, and then you add that to the current distance or weight of 4. Where do you get the current distance or weight of 4? Look on your graph. Do not look here. Look on your table. So in most cases, I normally indicate which node I am so that I know where I'm going to add. So the weight of moving from 0 to 1 via node number 4 is 2 plus the current weight of 4, which is 2. So it's 2 plus 2. So when you do your plus, don't look here because sometimes it gets confusing. Get this 2 for the current path plus the 2, which is here, you get 4. So therefore, the weight of 1 becomes 4, right? But before you update this to a 4, you need to compare your new weight to the existing weight. If your new weight is greater than the existing weight, it means there is already a shorter distance to this node. So don't update it, just copy this one, put it here. But if your new weight is less than the current weight, then you make this one 4. So in this case, 4 is less than 6. So in other words, we go 4 and you make it false. Do not make it true. The only way you make it true is when going to the next iteration. Where else can we go from 4? Well, that's it. So you copy everything else downwards, which means we copy our infinity here, false, our 3 here, false. And then we go to the next iteration. Repeat your steps. Copy everything that's already true. So in other words, we copy 0 here, we make it true. We copy 2 here, we make it true. Step number 2, identify the node with the smallest weight, move it down and make it true. And we move to that node. So we move this down. So this, we copy it and we make it true, which means we are now on this node 3. For the node, don't look here. This is node 3. So we are now on node 3, which is this node. So I'm going to my graph and saying, okay, I am now here. And I repeat the process. Where can I go from 3? From 3, I can go to 4, but I'm done with 4 already. See, it's got a tick. I don't bother this one because we have already found the shortest distance from 3 to 4. So it's covered. So from 3, I can only go to 2. That's the one that's left. And I can go to 2 with a weight of 2 plus the current weight of 3, which is 3. So it's 2 plus 3. So you take this one and you sum it with the current weight of the node where you are, which is 3. So that's why I'm marking this so that I know I'm going to plus this. So it's going to be 2 plus 3, I get 5, which means the weight of 2 is now going to become 5. So I come here, before I make it 5, I compare, oh, this is infinity, therefore this is less, I make it 5. So this becomes 5 and false. I'm done with 3, so copy everything else downwards. There we go. And next iteration. Step number 1, copy everything that's true. Step number 2, identify the node with the least weight, move it down and make it true. So this one here, here's the least weight. I'm now here. This is node number 1. Therefore, I'm going to node number 1. So I'm now here. So I'm going to just tick so that I can keep track of where I am. I'm on node number 1 here. Now, where can I go from 1? In this case, nowhere. There's no node branching from 1 where I can go to because these ones are all in reverse. So I cannot go to 0 from 1. I cannot go to 4 from 1. I can only go from 4 to 1. So I am done with 1. So when you're done, what do? You copy everything that's true. You copy everything that's left. So now I'm going to copy this node that's left. and make it false. Then I go to the next iteration. Copy everything that's true. So this one, true, 4, true, 3, true, 2, true. Next step, copy the node with the least weight, make it true. So I copy this one down, make it true. And I'm done because everything is now true, which means I have found the smallest weight from node number 0 to every other node, which means the smallest distance you can get from node number 0 to node number 1 is 4. This one is 6, which is this one. From node 1 to node 2, it's 5, which is this one. From node 0 to node 3 is 3, which is this one. There's no shorter distance. From node 1 to node 4 is 2, which is this one. And there is no shorter distance. So that is how you do the shortest path algorithm. Sometimes if you're going to draw this table, just remember that if you've got 5 nodes, like in this case, then you need 10 rows because each node is becoming true on every iteration. So if you're not draw this in advance and you're not sure like how far do I go, just count your nodes. I've got 5 nodes in this case because 0. So 2, 4, 6, 8, 10 because it's 2, 2, 2, 2 per iteration, right? So let's go and do another example, which is this graph here. The way the graphs are drawn doesn't really matter. It can be straight lines, it can be curved. It doesn't matter. It's just a graph. We've got all these nodes. I've got 6 nodes, so I need 7 columns, 0, 1, 2, 3, 4, 5, 6. And I need about 12 rows going down. So I draw my table. There I am. Okay. For all my nodes, for these nodes and my rows, 12. Or in this case, you need 16 because you've got 7 nodes, 14 because we've got 7 nodes. So 2, 4, 6, 8, 10, 12, 14. That's fine. Okay. Now let's go. When you start, you are on node 0. And you go 0, true. Always. Then you go, where can I go from node number 0? You can go to 1 with a weight of 2. So this is 2. False. You can go to 3 with a weight of 12. So this is 12. False. You can go to, it's only those 2 from to 1 and to 3. You cannot go to 2 because the direction. So everything else becomes infinity. So I go here, false, 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 false. Okay. Then I go to the next iteration. Step number 1, copy everything that's true. So I copy this down. Then I look at the nodes that are all false and I pick the one with the least weight. It's node number 1 with a weight of 2. So I move this down. I make it true. I know I'm now here. I'm on node number 1. So I go here. So where do I go? Where can I go from 1? I can go to 3, I can go to 4, it's only those 2. So from 1 to 3, it's 1 plus 2. Remember, you have to go and look at your node to get the current weight of your node. So 1 plus 2, I get 3. Therefore, the weight of going to 3 via 1 is 3, 1 plus 2. So this is going to be 3. Is it less than 12? Yes, it is. So we update it. If it wasn't, we were going to put 12 here. So in that case, we put 3, we make it false. Okay. From there, we can go to 4. The weight of going from 4 via 1 is 10 plus 2. We get 12. We compare with 4, it's infinity. So 12 goes here. So we go 12, false. Where else can you go from 1? I think that's all. So 1 is done. Copy everything that's left. So let's copy our infinity values here, our infinity value here, our infinity value here. Done. Next iteration. Copy everything that's true. So 0, true, 2, true. Okay. Then among those that are false, which one is the least weight? It's node number 3 with a weight of 3. So I copy this one down. I make it true. And I know I'm now here. We use node number 3. Therefore, I'm going to node number 3. Repeat. Where can I go from 3? Ooh, I can go to 2 with a weight of 8. So the weight of 2 is going to be 8 plus the current weight of 3, which is 3. And I get 11. So for 2, I want to put 11. I go to node number 2. Can I? Yes, it's less. So I put here 11, false. Where can I go from 3? I can go to 5, which is 4 plus the current weight of 3, which is 3. So it's 4 plus 3, I get 7. So 5 should become 7. Is it less than the previous one? Yes, it is. So this becomes 7, false. Next one, I can go to 6 from 3, which is 4, plus the current weight of 3, which is 3. So that's why I'm keeping this mark here, so that I know where I'm going back to look at. Okay, so 3 plus 4, I get 7. So 6, 7. So this gets a 7 and a false. Where else can I go from 3? I can go to 4, which is 3 plus 3. So 4 gets a 6. I compare here. Is it less than 12? Yes. So I put 6 here. And false. I'm done with this iteration. Next iteration, copy everything that's true. So you can see it's this repetition. Once you get the rhythm, you just keep doing it, you know. So I go 0, true, 2, true, 3, true. Among those that are still false, which one is the least weight? Is the least weight. It's node number 4 with a weight of 6. Keep this one down, make it true, and I know I'm now here. Right? So I'm node number 4, which means I go to node number 4. I'm now here. Where can I go from 4? I can only go to 6. And the weight of 4 to 6 is 6, which means the weight of going from 0 to 6 via node number 4 is 6 plus the current weight of 4, which is 6. I get 12. Therefore, for node number 6, I want to put 12. I compare with the previous one. Is it less? No. There's 7. So I ignore and just put the existing 7 back. Make it false. Where else can I go from 4? Nowhere else. So if the new weight that you're getting is less than the existing weight, then you update. But if the new weight is greater than the existing weight, you ignore, because it means there's already a shorter distance to this node than the one that you're getting. Anyway, now that I'm done with 4, copy everything else. So I copy here, 11, false, 7, false. Next iteration, copy everything that's true. 0, true, 2, true, 3, true, 6, true. On the nodes remaining, which one is the least weight? It's 2 of them. Pick the first one. It's an algorithm. I pick the first one. So I pick node number 5, move it down, make it true. So this becomes 7, true. I'm now on node number 5. So I'm now here. So I can come here, there. Where can I go from 5? Nowhere else. So I'm done with 5. Well, what do you do after that? Copy everything else. So we copy our 11, false, 7, false. Next iteration, copy everything that's true. 0, true, 2, true, 3, true, 6, true, 7, true. Among those that are left, which one is the least weight? It's node number 6 with a weight of 7. So we move this one down, we make it true. So on node number 6, I go here. From 6, where can I go? I can only go to 5. But as you can see, 5 is done with already. So where else can I go that is still false? Well, nowhere else, because node number 5 has been confirmed. And that's why I can confirm with this tick on my graph. That's why I put these ticks so that I can keep track. So from 6, there's nowhere else I can go. So I'm done with 6. What do you do? Copy everything else that's false. So we copy 11, put it down here. Next iteration, copy everything that's true. 0, true, 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 3, true, 6, true, 7, true, 7, true. Among those that are left, move it down, make it true, and there you go. Everything is done. That's how you do the shortest path algorithm. So you just need to keep repeating this until you get it. So what I would advise is try and do with me. You can rewind, press play and then try and do it with me and see if we are moving in the same direction. You do this 2-3 times, you get it. That's how it works. It doesn't get more complicated than this. That's how you apply the shortest path algorithm. The other 2 things we need to look at is the breadth first traversal. We need to look at the adjacency matrix, and those we'll do in the upcoming videos. Otherwise, keep practicing the shortest path algorithm. If there are any other questions you think are tricky, bring those. We can chat on our Telegram groups, or we can discuss those in our live classes. Otherwise, for the shortest path algorithm, that's it. Cheers.